Hi everyone, Land Assistant here for our math problem for today. Solve for the value of x given this equation, 27 raised to x plus 343 raised to x all over 63 raised to x plus 147 raised to x equals 37 over 21. This is a kind of algebra problem that will really test our knowledge of algebraic manipulations. You can pause the video and see if you can solve this algebra challenge. Now let's solve this problem together. First is we are going to express 27, 343, 63, and 147 as their prime factorization. 27 is 3 cubed, 343 is 7 cubed, 63 is 3 squared times 7, 147 is 3 times 7 squared, all the rest are copied. Then let's recall some laws of exponents. This part here is similar to this part. So applying the power of a power rule of exponentiation, we can write this 3 to the third all raised to x as the base 3 times the product of the exponent 3 times x. But since multiplication is commutative, we can also write this as y times x. Reversing the process, we can put y back and the exponent x outside. In other words, we can interchange this exponent 3 and this x to arrive at a form like this. Notice now that we switch the inside and the outside exponents. The reason behind that is we'll be able to apply a special product called the sum of two cubes so that we can simplify the numerator. And our hope is to be able to cancel out some expressions in the numerator with the factored form of the denominator. So let's continue our solution. Now notice that there is a common factor in the denominator. So let's copy all the rest except the denominator. And let's factor out the common factor here. The common factor between 3 raised to 2x and 3 raised to x is 3 raised to x. The common factor between 7 raised to x and 7 raised to 2x is 7 raised to x. Then this first term divided by 3 raised to x times 7 raised to x will cancel out the 7 raised to x. 3 raised to 2x divided by 3 raised to x would be computed using log exponent number 2. So we'll just copy the common base 3 and subtract the exponent 2x minus x to get this x. The same explanation for the quotient of 3 raised to x times 7 raised to 2x divided by 3 raised to x times 7 raised to x. This 3 raised to x and this 3 raised to x, when divided, will result to 1. 7 raised to 2x divided by 7 raised to x. Applying log exponent number 2, we copy 7 and subtract the exponents 2x minus x to get this exponent x. Let's focus now on the numerator. Notice that the form of our numerator is similar to the sum of two cubes special product. Therefore, this numerator here cannot be written similar in form as the right side of this identity, where our a is 3 raised to x and our b is 7 raised to x. And so it will now look like this. We'll have a plus b, which is now this part, and multiply it by the quantity a squared minus ab plus b squared, which is now this part. Notice that this is our a squared, this is a, b, this is b squared, which is exactly following this formula. And of course, this is a plus b. Now, let's copy all the rest. And then from here, notice that this 3 raised to x plus 7 raised to x is exactly the same as this. So we can cancel this out. So what's left is now this second factor times this first factor in the denominator. This is now what's left. Let's recall again our log exponent number 3 to simplify this part here. So this will become 3 raised to 2x minus 3 raised to x times 7 raised to x. And then this part here, applying the power of a power rule, that is equal to 7 raised to 2x. Now, you have here a multinomial divided by a monomial. So we can distribute the monomial divisor to each of the terms in the numerator to have 3 terms like this. Then, let's simplify. Notice that this 3 raised to 2x is just the same as 3 raised to x times 3 raised to x. The same explanation to this part here. Now, simplifying 3 raised to x divided by itself is 1. Then, this part here is also equal to 1. Then we can also cancel out 7 raised to x divided by 7 raised to x. So what's left is this part here, 3 raised to x over 7 raised to x. Then this one here, copy the minus sign. And this part here, 7 raised to x divided by 3 raised to x. Copy the right side. Then from the quotient law of exponents, we can also write 3 raised to x over 7 raised to x as the quantity 3 over 7 all raised to x. The same explanation to 7 raised to x over 3 raised to x. Notice that 3 over 7 and 7 over 3 are reciprocals. So let's do some u substitution here. We let u be equal to 3 over 7 raised to x. Then this quantity 7 over 3 raised to x is equal to the reciprocal 1 over u. Then let's re-express this in terms of our variable u. So we now have u minus 1 plus 1 over u equals 37 over 21. Then let's get rid of the denominators of this equation by multiplying by 21u and simplifying. We now have this equation 21u squared minus 21u plus 21 equals 37u, which is a quadratic equation. So let's write this in such a way that the right side is equal to 0 so that we can apply the zero product property. This is now a quadratic equation that is factorable, and the factors are the quantity 7u minus 3 times the quantity 3u minus 7 equals 0. So applying now the zero product property, 7u minus 3 equals 0 and 3u minus 7 equals 0. And we now have u equals 3 over 7 or u equals 7 over 3. But we are not after u, we are solving for x. But what is the value of u? U is equal to the quantity 3 over 7 raised to x. So from here, we now replace this u by 3 over 7. We now have this equation. Notice that you have the same base here. It's implied that the exponent is 1. So that means the value of x is equal to 1. And at the right side, substituting again the value of u to our assigned value for u, we have now 7 over 3 equals the quantity 3 over 7 all raised to x. 7 over 3 and 3 over 7 are reciprocal, so let's re-express 7 over 3 as 3 over 7 raised to negative 1. We have the same base, the exponents are equal because these two quantities are equal. So that means x is equal to negative 1. And we now have these two values for x. That is the solution of the original equation. And so this is now our final answer. So this is indeed an algebra challenge. Thank you very much. This is Lanka Assistant, and we hope to see you again in our next video. Bye for now.